real-world problems. So in the last two videos, we were able to see whether or not two ratios were equivalent. Did that a couple of different ways. And then in the most recent video, we were able to solve whenever we had some sort of ratio and had a missing value. So using those simple tools, we're going to apply those to word problems now. So having hopefully scanned through this word problem, you've seen that Trent goes on a 30-mile bike ride every Saturday. He rides the distance in 4 hours. So literally, if I only read there, I'm thinking 30 miles for 4 hours. At this rate, how far can he ride in 6 hours? Now, the word superfluous means more information than you really need or will use. So there's no point in them telling us that this happens on a Saturday. So it's good to always kind of eliminate any superfluous information that you might have. And I don't think a picture is necessary, but let's go ahead and draw a little horizontal line in some open area here to the side. And we know that this is 30 miles, and we also know that it takes him 4 hours to do that. And whenever we deal with problems on how quickly things get done, we're thinking about the word rate. And I know that in the word rate is the root for ratio. So how quickly things happen over time. And not necessarily time, just could be like the ratio of boys to girls in a class. It could be the ratio of people that do wear glasses to those that don't wear glasses. And since we're trying to find out the mystery distance that he rides, maybe it's also nice for me to set up the other distance that he would ride in the 6 hours. Well, if he can do 30 per 4, it seems to me like this number down here would have to be larger than 30. And as I often indicate and hint at on word problems, it's good to sort of brainstorm it in a way like that, to put a little bit of pre-focus into the game so that is my future answer headed in the right direction? So here's a ratio on the left equal to a ratio on the right. And since we always talk about miles per hour, I think it's almost kind of clear that we could be like, well, there's 30 miles per 4 hours. So I put mi and then 4hr. And the reason I like to map it out like that is because now, when I go to write 6 hours, I definitely wouldn't write 6 hours up here, because my units would not match up. By going through it as clearly as I have, I would know, okay, here's my 6 hours here. You could put HR, HRS, either way. And that means we have a missing value that we're solving for, and here's x. Now we, of course, could scale this up by a factor of 1.5 and do that to here, and figure out that it's probably 45. But since we just learned that cross-multiplying deal, here we go with 4x equals 30 times 6. And even though that's 180, let's wait on multiplying that out. So we've cross-multiplied, and now I'm going to divide so that I can solve and be left with only my variable of x on the left side. This one actually does cancel out nicely, so I'm going to say, well, both of these are divisible by 2, leaving me with 3 and 2. And then I can take half of 30 to get 15, and 15 times 3 does give me 45. And since this is a word problem, how far can he ride in 6 hours, we're going to have to include our units at the very end of 45 miles. And I also tell you all the time that with word problems, you want to check this in the backdrop of the problem. Well, I mean, if you can, go 15 every 2, and I'm getting this based on that, was 15 every 2, I can then triple 15 to get 45. No matter how I look at this, the word problem does check out. And to be totally transparent, we set up a ratio on the left, ratio on the right, how quickly things happen. We are comparing two different things, miles to hours. It takes 7 minutes for Isabella to walk around the track twice. At this rate, how many times can she walk around the track in a half hour? Now we have a little bit of an issue, and our issue is that our units don't agree. the time that we're given here is in minutes. The time that we're given here is in hours. And let's ask ourselves, would we rather convert minutes to hours? Well, that would mean I'd be dealing with 7/60ths of an hour. Well, that doesn't seem very clean to me. So because of that, I think I'd rather convert hours to minutes. And since I know that there's 60 minutes in an hour, I'm going to go ahead and get rid of my ink here, and I'm going to just write 30 minutes. I can do that close to the words. And if this was my textbook problem, I wouldn't have the problem written in front of me. So maybe I would use that side area to write 1/2 hour equals 30 minutes. Or 60 divided by 2 equals 30. But I'm keeping that off to the side so it's not in the way. And then I have MINS written as an abbreviation for minutes. On your own, see if you can set up the fraction, the ratio, where you're going to be comparing two different things. And my hint would be, laps. How many laps is she going around? I'm going to put the ratio up in 5 seconds. Now let's say you did minutes up top and laps underneath. That's okay, just as long as they match up. Because if I flip them and then cross-multiply it, I'm going to get the same result. But usually something happens over the time period, so I'm thinking of this as 2 laps per 7 minutes. And then if this is 7 down here, and that's 30, I'm thinking that this 2 would probably be bigger. Now if you, I don't mean to be too big of a jerk here, I'm just kind of being a little bit blunt, but if you thought that said 21 here on the left, that means you are letting me do the work and not thinking enough on your own. Or confused. So if you're confused, ask questions. So here I am cross-multiplying, and then I'm going to get 7x equals 2 times 30. And now from here on out, I'm going to let you solve it on your own and put the answer. So I'll show the rest of it in about 4 seconds. So yeah, I'll briefly talk about the work, but by this point you've kind of solved it a bunch of times. So yeah, we did divide both sides by 7, and then we got a decimal. And this one did round to the nearest hundredth, because after that digit I would have a 1, so I would just leave it as it is. So 8.57 laps. Again, how can we check this? Well, if I'm thinking about going from 7 to 30, 7 times 4 is 28, so I should get a number that's, maybe a little bit more than 4 times those 2 laps. And so here we are. This seems reasonable to me. I turned to a friend. I asked them about it too. We're good to move on. Read this on your own. Pause the video if you need to. But the scale for a map is 2 inches is equal to 9 miles. Now this means that if I look on a map and I have something that's 2 inches long, this really is reflective of 9 miles. So it's the ratio of a distance in inches to a distance in miles, and that's just to represent scale. The distance between 2 points on the map is about 1 3/4 of an inch. Well, I don't want to deal with a mixed number in there, so go ahead and turn this into the decimal 1.75. By changing that to 1.75 inches, I now can do math in the calculator a little bit easier. And I do think that that's easier than dealing with 7/4 as a fraction, so we won't change that. What is the distance d? So I circled that in red just because you don't have to, because we don't know what this value is. We're going to use d as our variable. So now I'm going to rewrite this 2 over 9, and I am still going ahead and showing these tick marks to represent inches and mi to represent miles, because in this first step, as I set up the actual values, it's a ton of help to make sure that you're in the right spot here. So here's 2 inches per 9 miles, 1.75 inches per d miles, and then when I cross multiply, I'm going to get rid of those units. So here's 2d equals 1.75 times 9. And when I say get rid of, I don't mean that I am eliminating them, like the units aren't disappearing necessarily. What I'm saying is that I'm not bothering to represent them. So here's 2 over 2 going away, which I choose because of that. And then I type this into my calculator, and I get d is equal to approximately 7.89 miles. And pause it, give yourself a moment to do a logical check before I start to talk about it now. Alright, so here's the deal. We got 2 inches. 1.75 smaller than that. We got 9. Our new number should be a little bit smaller than that, and I would say that that is. So that's good for some word problems. When we get assigned this homework assignment, this is going to be the book work that will go with this. Maybe that's today, maybe it's a day from now. Who knows? But this is the third of 3 videos representing ratios and proportions in this chapter.